everybody, my name is Bernardo. It's a pleasure being here with you again in one more IGLC. Today I'm going to present one exploratory study entitled Using BIM with the Less Planar System to Improve Constraints Analysis. This paper was produced by myself, Reck, Fireman, Rodrigues, and advised by Professor Eduardo Isatto. Starting from the introduction, we must remember that the less planar system has already been widely implemented by construction companies, those that seek to improve reliability in the production and construction sites. And we identify the medium-term planning as the main element that make up less planar system. And also the objective is exactly to protect the workflow by identifying and remove constraints before the activity starts. Some different studies have already been conducted. A systematic literature review identified that one of the major shortcomings when applying medium-term planning lies precisely in the identification and removing constraints in advance. From the less planar system to BIM, we may say that BIM represents the components of the enterprise by means of digital objects that carry graphic geometries and information, as well as parametric roles that allow them to manipulate intelligently. As a result, we have a model of the project will be a common source for our project participants through all the life cycle of the projects. The joint application of BIM, the Build Information Model with Less Planar System, has already been strongly suggested as a way to assist and streamline the process of identification and removing constraints. We bring here one study that had compared two case studies, one using the less planar system and another using less planar system with BIM. And even without the use of BIM models in look-ahead planning meetings, the coordinated use of less planar system and BIM generates an increase of the percentage of plan completion, a decrease in reasons for non-compliance, a shortening of the meeting durations, and a decrease in the total number of design RFI. Data from 5 case studies from 3 different companies have been so analyzed in this paper. And we bring here the main objective is exactly to analyze how integrating BIM and the less planar system can enable constraints in the medium term and work packages in the short term. As a research method, we bring a multiple exploratory case study, and the criteria for selecting those 5 studies were based on the planning and control methods that were based on less planar system. The companies had the history of implementing lean tools. We got access for the information, and all the companies are in an initial stage of implementing BIM. We divided this method in 2 phases, one considering identifying the constraints in medium-term planning that could be modeled in BIM, and the second is examining the percentage of work packages that could be modeled considering the short-term period. In all of them, we went through a database. We categorized considering the category or the stage of the construction phase, and also we worked on focus group to identify the modeling package or constraint in each horizon of the less planar system. And we have here the 5 case study. We have 2 residential case studies, 2 commercial case studies, 1 industrial case studies, and we had the amount of 217 constraints and 1,242 packages identified throughout those the data we collect on those studies. Now going for starting the results section. From the data on the medium-term constraints collected for construction works, we could develop this matrix here and analyze which category of constraints by type of construction works are best suited to being modeled in the medium term. So we can consider the difference between typologies and stage of the construction work, and the matrix also enables us the following analysis that we will highlight in the following slides. Equipment. We can say that equipment constraints have an excellent opportunity for being modeled in the medium term. From 80 to 100% of the medium term constraints into this category could be modeled. For example, dimensioning which type of crane or platform could be contracted for the industrial construction work, or up to what height of the bottom of the concrete pump should be reached the concreting. Also, we have some characteristics for those different residential and commercial projects. If you pay attention to material constraint, the data analysis show a particular contrast concerning the possibility of modeling between the different types of construction works, and the stage of those works appears in this case of study. Considering the industrial works with engineered to order type of production, there is the possibility of modeling all the constraints categorized as material, since each element has its own characteristics, and monitoring and tracking its status is a key factor for the performance of the construction work. If you go for the residential and commercial works, most materials do not need to be modeled since they are more standardized. And it's also interesting to analyze the security constraints, show that the vertical works, they enable modeling of collective protection in their interface with facade elements and the method of execution of the facades and the structure itself. Another interesting analysis that can be made in that constraint is the category that tend to be analyzed at different stages or moment of the construction work, which reflects the difference between the percentage of constraints that can be modeled. If you go for the industrial works, for example, these constraints tend to be less analyzed due to the short cycle of stages of works and the modularization of the construction works. Going to the analysis of the short-term data, the second results we bring here, this figure presents the graph with the percentage of package that can be modeled in the short term concerning the stage and the type of work. It's important to point out one of the limitations of this paper is that there are works performed by different companies and different moments and project typologies. However, we could highlight some aspects. Those aspects may understand that all causes of project can be modeled in the short-term data. Access categories can also be modeled, and it represents the interference of the stages of the product pieces and equipment and workflows. Materials we may model considering the losses above those expected in budget, and it's important to point out that we could have more precise quantitative estimative of materials since you use BIM since the beginning of the project. When you talk about the equipment category, a detailed study in BIM model could avoid the cause of acquiring inappropriate equipment for the activity or bad dimension. In resume, the joint analysis of medium-term constraints and causes of short-term completions are urgent, with high capacity for modeling the categories of project equipment, access, and materials. As a conclusion, we may say that analyzing the constraint identifying the medium-term planning and the percent of package elaborating the short-term planning meeting that could be modeling BIM, we may conclude the integration of BIM and less planner let the constraints in medium-term planning be identified and removed in a more agile and efficient way. Using the BIM 4D to support the modeling of constraints could be seen that the use of the BIM model throughout the PPC process brings benefits to planning of the construction project. We identify also a great potential for modeling medium-term constraints and cause of short-term in the BIM model. And we can say that these occur mainly for those that refer to project equipment, work safety. And the use of BIM can be different in the planning horizon defined by the less planner system. In the medium term, BIM can use to allow simultaneous and visualization of the position of teams, equipment, the sequence of activities, simulating and visualize and understand the workflows. In the short term, BIM enables packages to be visualized in greater detail, thus facilitating their current definition and can let different management systems come under integrated control. We also highlight that being in planning meetings, both in the medium term and in the short term, since the model allows the participants to be involved and to have a common understanding and in the interpretation of the strategy defined in the enterprise and in the projects in those case studies. As a further study, we suggest the common use of BIM and less planner by integrating the modeling of those attributes and constraints identified in the comparative case study that lets the potential gains be measured. So I'd like to thank you everybody again and the opportunity to present this study and exploratory case studies, and I'm open here for questions. Thank you very much.